Now, oftentimes when you talk to programmers, they ask you, hey, what design pattern should I use? Well, unfortunately, when people look at patterns, they tend to often ignore design principles. And if they look at patterns without looking at design principles, we often end up using the wrong pattern, which actually can make things more worse. So I consider the design principles to be the force behind the patterns. And if we know what principles may come in and play or interplay, then we get to choose the right patterns to use. Now, we're going to talk about some very important patterns or fundamental patterns I've come to realize is important. So we're going to talk about some of these design principles. Now, where do we really see them? The reason I want to emphasize where to see them is I find that much like how to sit down when you design and say that you're going to use a set of patterns may not be a good way to design software, I also find that it's not really productive to sit down and say what patterns am I going to use or what principles I'm going to use. That is like opening the medicine cabinet and then saying, I wonder what tablet I can eat today, right? That's not a good thing to do. You don't want to open the medicine cabinet and say, I wonder what tablets I can have today. Instead, you should start, first of all, if you can avoid the medicines, that's even better. But otherwise, you say, what problem do I have? And then find the right tool for that, right solution for the right medicine for that. So a right time to use these principles, in my experience, has been during tactical design in test-driven development. So I like to see design as twofold. A strategic design where you apply some very coarse-grained concepts, a big vision on the project structure, architectural level decisions probably that you are willing to vary later on, and then more of a tactical design decisions where you get down into methods and classes and interaction between classes, and design principles, I believe, play a lot better role at that level when we are applying this to test-driven development. Why should we use them? And the reason is these principles help us to overall think about some potential problems in code and remove some of those along the way. I want to talk about some core principles today, and these are the principles I would like to talk about. And the first one I want to talk about is called the DRY principle. The DRY principle was mentioned in The Pragmatic Programmer. And if you've not had a chance to read that book, I would highly recommend reading that book. It's called Pragmatic Programmer. And then Dave Thomas and Andy Hunt wrote this book back in 1999-2000 timeframe. But it's a timeless book in a lot of different ways. I can't recommend enough the book Pragmatic Programmer. And in the Pragmatic Programmer, we talk about this thing called the DRY principle. The DRY principle stands for don't repeat yourself. Now, why shouldn't we repeat ourselves? And what does the DRY principle really say? Well, it says, in simple words, it talks about certain things we need to follow in code. And mainly what it tells us is that it says that every knowledge that we have in the system, right, in the system should have, if I know how to type this morning, should have a single authoritative representation. Right? So that's what it says, first of all. Every knowledge in the system should have a single authoritative representation. In other words, when you are designing an application, you have to identify a certain knowledge, right? A piece of concept or knowledge. Say, that's an idea, a concept or knowledge I'm implementing, and that lives right here. I'm not going to duplicate this in several different places. Now, how many of us have seen code being duplicated everywhere? Everyone has seen that. Absolutely, we have done that, right? Some of us actually have done it, right? How many of you duplicated code? That's courage. Absolutely. I did this as of last night, right? Absolutely. Why? In fact, this is a couple of weeks ago. I was writing some code, and I was writing some test, and I wanted to make this test pass, and I quickly realized, you know what? I've done this before on this project. I know where I did it, and I did it over there. And within about 3 minutes, my test was passing. I was happily marching along, and I stopped and said, wait, how did I make that test pass so quickly? And I went back and looked at my code, and it was a shame. I had copied and pasted my code, and I didn't even feel it, right? It becomes so natural, so second nature. Sometimes we copy and code, and we don't even realize it. So duplication of code is evil. I was talking to a client, and the person said, you know what, every 2 months, I keep fixing the same bug. I said, oh my gosh, do people actually go back and put the bug back in the code? He said, no. This code has been duplicated in so many places. We keep discovering it. And every time we discover this duplicated code, we have to fix the bug again. I said, how does it feel? He said, that sucks. And I said, well, when you do find this at that time, you remove the duplication and refactor the code, right? And there was a bit of a silence, and he said, that's a great idea, right? Well, if you don't, how do you ever put an end to this, right? It's going to be still in duplication, so you got to remove that. But often that principle is confused to be duplication of code. It is a lot more than duplication of code. It's duplication of effort. This is where it gets a little tricky. You argue, well, sure, if I copied and pasted this code over there, that is really bad. Now, let's talk about copying and pasting code for a minute before we go any further, but we all know copying and pasting code is really bad. But nobody in their right mind is going to copy and paste the code and walk away, right? You copy and paste the code, and you change all the variable names, right? Because you have learned this in school, right? The teacher said, do this homework. You're like, this is a serious homework. Why should I redo this? And you copy and paste it, but you're smart. You change the variable names, method names, change a few things here and there. I'm like, I'm done, right? This was easy homework. Yes, I know it, right? I'm a faculty. I know students do this. So what do? You use tools that look at the code structure, the AS abstract syntax tree. Hey, look, the AST is the same. The structure and the code are same, even though the variable names are different. Maybe there is a duplication here. So there are tools to find that kind of duplication. And eventually we can get rid of some of those, right? But the problem really is, it's not just the duplication of code, but the duplication of effort. I was talking to a company, and the boss, we had the entire team in the room, and then the boss said, look, my team said they are building extensible software. Every day they'll come to me and say, we're building extensible software. And so we were happy, man, marching along, and it came along a time when we had to redeploy, and within a week of deployment, there was a change request from the customer. So I told my team, yeah, we should be able to handle that very quickly. And I came back to my team and I said, can you make this change? And the team said they need about a few weeks to make the change. I said, wait a minute, why do you need a few weeks to make this small change? And the team said, because we got to make a change to the database, we got to change that code, we got to change that, we got to change that, and we got to change all these. And then, of course, we got to make sure everything works. That needs a few weeks. And so the boss said, well, if that's what they are telling me, they need a few weeks to make this change, what does it mean that they keep telling me every day the code is extensible? And I said, yes, it's your fault. And the manager said, my fault, what did I do? And I said, the code was extensible until you asked it to be extended, right? I mean, if you didn't ask them to extend it, it would have been extensible all along. Right? That is an example of duplication of effort. And the team would say, well, it's not the same code we are changing. We got to update the database schema here. We got to change that code over there. We got to change this other code to handle this code right here. But the API has changed, so we got to add these properties here, right? Well, we will argue this is a different, but it's a duplication of effort. I'm going to give you one example, just one example, just to get a feel for what that really means, right? And I'm a big fan of really good tools, lightweight tools. And I'm a huge fan of Grails as well. So I'm going to give you just one example of Grails. And the reason here is not to emphasize the issue to use Grails. You should if you want to. But my argument is that there are tools like this that can change our assumptions and can do things really nicely for us. I'm going to use some scaffolding here to get around. So I'm going to create a Grails application. We'll call it as create app. And I'm going to call this as, let's call it as team app. Right? Actually, let's call it as company app. So I'm creating a company app, just nothing, no code existing right now. But I want to illustrate a little bit of a point about how we could actually handle some of these. And if they can do it, guess what? We can do it too, right? We can go back to our offices and say, hey, how do they handle it? How do we really implement some of these techniques and create code for ourselves? So what I'm going to do here is I'm going to create a Grails create over here, create domain class over here. And the domain class I'm going to create, I'm going to call it as, let's call it as team. So I called it as a team, and that's all I've done so far. And let me show you a couple of different things you can do. Well, in general, you would write quite a bit of code to make all of these work, but I'm going to just show you an example of things you can actually learn from and implement. So I'm going to create one more. I'm going to say create controller for this class we just created, which is the team class, and I've done enough of generation of code right here. Now let's go back and take a look at the code we have so far and see what we're going to do. I'm going to go to the team class for a minute, and let's take a look at what's in the team class at the time. Well, notice that the team class doesn't quite have anything useful or significant at this time, and I'm going to kind of move these a little bit around so it's easier for me to work with, and let's kind of use that. So let's go ahead and put this up here. So that's my team class. Actually, let me keep this here. Okay, so we saw the team class and how we were able to use it. Well, what I want to do here in the team class is I'm going to go ahead and create one field. We'll create this as string name. While here, let's also say contact email. So 2 fields, right? Contact email. So I created 2 fields in this class. That's what I've done. So those are my 2 little fields. Now I want to go to the controller, and the team controller, I'm going to just take a short route here. I'm going to ask it to do code gen because the scaffold equals true. That's all I've done. So let's remove all of that. And let's go back and say Grails run app to take a look at what we have so far. Now in this case, I want to run the application, so as soon as it comes up, we'll open it, and we'll take a look at what the application, and I want to create a team object. But when I create a team object, I want to emphasize a few little rules. And I want you to take a look at 2 different areas where we would have to do this, and that will kind of help us to see the duplication concern that would arise immediately. So what I'm going to do here is I'm going to go to create a team, but I'm also going to go to update a team also, right? So notice in this case, I'm going to go to the app, and I'm going to go to the team controller that we have. I'm just showing you minimal code here to work through this. And in the team controller, you can see in this case, it allows me to create a team. So I'm going to click on new team. So when I click on new team here, I'm going to go ahead and enter a team's name. We'll call it as team 1. And I'm going to simply say team 1 is the contact email. Also, click on create right now. And I'm going to create another team. So team 2 will create as team 2. I'm going to create team 2, same thing again here. Click on create. Notice now I have 2 teams on my hand, right? So that should be fairly easy to see. I have 2 teams sitting here. Well, here's the other one. I didn't click on the create, I guess. So team 2 and then team 2. And we'll go ahead and create this team 2. There we go. And we have 2 teams. Well, great. But here's the problem. I'm going to create one more team, but this time I'm going to give a name as team 3. Now notice what this page is. This is the create page, right? We're trying to create a new team. I'm going to call this as team 3. Should be okay, right? What if I call this as team 1 one more time? Well, that would be a duplication because I already have a team 1, and I want to say that team should be unique in its name. So keep that in mind. That's one place, which is the create page, right? But on the other hand, I might also go back to the team list, pick up team 2 at this point, edit team 2, and change the name of team 2 also back to team 1. So this is the other place where we have to worry about it, right? So when you create something new, you have to make sure you don't have duplication. When you modify something that exists, you have to make sure you don't have duplication, right? Well, a lot of us have developed web applications, and what do we normally do? We write some code in controllers, we write some code in views, which is not a right thing to do, but we tend to really look for things and say, I want to make sure this is not duplicated. Well, tools like Grails think about these kinds of principles from the ground up. So when I'm introducing Grails, I would often say it's a framework that emphasizes the drive principle quite a bit. Let's take a look at how. I'm going to go back to the code right now, and in the code, right here in the code, I'm going to introduce one little rule. And the rule I'm going to emphasize in this case is going to be in the domain class itself. So right here in the domain class, I'm going to say that the name, that property name, must actually be unique. So I'm going to say unique equals true, and I've emphasized that it's unique. Now I go back, that's only one change I made so far, and I go back to the application now. I'm going to go back to the controller, and this is an in-memory data, I blew it away. I'm going to create team 1, so I'm going to say team 1 over here, and this is going to be team 1, and click on create, and if you notice we have a team 1 created. I'm going to create team 2 one more time like we did the last time. So here's my team 2. And now I go back to the list of teams. You can see that there are 2 teams again. But I created team one more time. I'm going to say team 1 one more time in this case. And sometimes it doesn't recompile properly. So if it blows up, I'll just recompile it. So bear with me for a minute. And that's the blowing up I was talking about. So let's go back and refresh this and make sure that it recompiles the code properly. So that's just, it's a development environment that doesn't really recompile properly all the time. But nevertheless, let's go back and give it a try one more time. So in this case, what I'm going to do is I'm going to ask it to again create the team. So bear with me. Actually, let's kind of do something else to help us with that. So I'm going to go back to Bootstrap and create that so I don't have to duplicate that effort. So I'm going to say over here, import. Let's bring a team into the picture. I'm going to say new team. And in this case, I'm going to say new team. And let's say this name is going to be team1 and contact email. That's what I called it. Contact email. And I'm going to say this is going to be team1@example.com. I'm going to save that, assuming I didn't make any syntax errors over there. And then this is the team2 that I want to save and start with, right? So great. I got these two team examples to work with. I'm just going to recompile that way I don't have to retype that. Let's go back to those 2 pages one more time and see what happens. Again, to refresh your memory, what I did here is I just added this constraint in the domain class. That's the only place where I made the code change for that purpose. So go back to the to the UI now, to the browser, and take a look at what we have. So if I revisit it, go to the controller this time, and in the controller, we can already see those 2 teams nicely sitting and waiting for us. I'm going to click on new team this time. And I'm going to call this as team1 again, and I could call this whatever I want to, team1@example.com, let's say. And I try to click on create, and notice I get an error telling me I cannot do this because a team name must be unique. Well, that's great, but I'm going to get around it. Go to team2, sneak around, and try to modify team2's name to become team1, and you can see that it's catching me right there as well. And efforts like this is very important to me. We do things in one place, and that should propagate all the way. Now you may say, okay, I'm a little bit convinced, but because this is a server-side validation, uniqueness is a server-side validation, so you go off all the way to the server, and what does the server do? The server says, wait a minute, there's already a data here in the database, whether you're trying to create or to update, I'm not going to let you do that. Well, what if you have to do client-side validation? You got to do both at some time, right? So if you want to do client-side validation, what do you have to create? JavaScript, possibly JavaScript. And that kind of drives us crazy, right? Because now not only do you have to create JavaScript, what else do you have to do? You still have to do server-side validation as well. You cannot simply do client-side validation and say, I'm done, because I could send you a post request directly through a curl command, for example, or other means, and you have to do server-side validation too, and what now, right? You may argue, sorry, you have to really duplicate the code. But the drive principle says, no, you don't want to duplicate that effort, single point of authority, and generate the rest of the code as you would. Let's take a look at an example here. Notice what I'm going to do. Again, this is one simple example to show. I'm going to say contact email is going to be email, and it's true. Again, I added that one thing. That's all I added. Now I go back to the view this time, and I'm going to open the URL and visit that URL right there. So let's go ahead and do that. So when I visit this, and I'm going to go back to our application, go to team1, and of course in-memory data that got blown away, don't worry about it. So I'm just going to say team1, but this time I only say team1 here. Actually, I should refresh it. It didn't do it. Okay, let's do that. So let's go back and refresh this. On contact email, I said email. Oh, you know what? I made a mistake, didn't I? That's why. So let's go ahead and remove that. There we go. So let's go back and retry this. I'm regenerating the server-side code. And I want to go back and have it create a new address, email address, but there's a rule we want to follow. And what is the rule? That emails must follow a certain format, isn't it? So I go back to the app, and let's go back here to create a new team. And as soon as I go there, I'm going to say team1, and I'm going to enter P. You're already able to see that it's in red in color on the client side, right? Now, how in the world can that be done? Well, again, it's the drive principle. It doesn't matter how you do it, because that depends on what you're doing. But the point is that you are going to do it. Well, in this example, it was fairly simple. If you notice, they were smart enough to create HTML5 tag and made it an email tag. This really came from the fact that we said that this is going to be an email field. So what they did was they took that single authoritative representation and decided to write server-side validation, but also push client-side matching code. This could be HTML5, this could be JavaScript. I simply don't care, right? The point is you take care of that effort so you don't babysit this over and over. Now, one of the things I've come to realize, I'm not a great programmer, I'm a stinky programmer. But over the years, I've been hurt several times by my own mistakes. And I've learned my lessons. Right? That's what experience is called, is that you learn from your mistakes. And I've learned my mistakes. And one thing I've done over the past few years is I have eliminated duplication. And there are days when I sit down, it will be late in the night or early in the morning, I got to fix something really quick in my application. I don't have time. And I would go in, and within 5 minutes, I would make a fix. And I have to admit to you, I would be like amazed. I'm like, really? This actually worked? That's how much distrust I have about myself, you can see, right? And I would go back and see why it worked, and I would kind of pat myself on the back and say, there, you did a good job of not duplicating the effort, and now when you had to make a change, it just worked, rather than you have to babysit through every step of the way and change it. So in a sense, I just wanted to use this as one example to show you this, but there are several other places where we can actually do. And I remember very clearly being in applications where I failed on this very, very well, where we duplicated the validation logic in many places, and then we had to go back and fix it. And that increased the cost of development, cost of deployment, and that becomes really expensive. So all I'm saying here is, sit back and think and say, how can we eliminate duplication of effort? And it may not be easy, right? It may not be easy. If it's easy, everybody would be doing it, but we are there to solve real problems, and that's the whole idea. Any questions or comments on drive principle before we go? Yeah, please.
You have mentioned that email, when you get email, it has used HTML5.
That's right.
What if my application is browser compatible?
Right. And again, keep in mind, that's just one example I wanted to show you, right? I'm not interested in digging that. In a Grails course, I would. But the point really is, you really need to handle those. And if you are saying, you know what, okay, maybe for browser compatibility purposes, I do have to integrate JavaScript, generate the JavaScript from a single authoritative source rather than writing the JavaScript, right? And that is what we are hired for, the smartness, right? If you and I are going to keep duplicating this code and walk away, we're not professionals at that point, right? So we need to sit back and say, what is the problem and what are the solutions to the problem other than duplicating effort? That is the most important thing. And maybe we'll sit down and we don't know an answer. We can bring in another person, and maybe 3 of us will figure out an answer. But the point is we did work towards finding that answer rather than duplicating the code and walking away and creating a mess for the organization to deal with later on, right? That's professionalism for us to deal with. Any other questions? You can repeat the questions if you want to. That's fine, right? That dryness is okay. All right. So, yeah, who's that? Wave at me. Yeah, there you go. Right. Maybe. And I think that's all my job is done. The fact that you're even asking those questions, right? And that is what I'm emphasizing. I cannot answer the question for every language, every framework, but that's what our job is, to really go back and figure out. And you say, well, you know what? Maybe I can use a code generator to generate it. Maybe I can read from a configuration file. Maybe there's a Spring configuration I could use. The minute we get that little pain, we're going to sit back and say, let me start searching for an answer now, because duplication is no longer a solution, right? And you're going to hit thousands of such problems. But the point is, you got to clear each one of them and start finding the answers. And the first few are going to be the most difficult to solve. And the third one, the fourth one, fifth one becomes a lot easier. And then there are tools available, right? Great number of tools available, frameworks available, libraries available. What's not available is our desire to go find them. And that's what I want to change. Yeah, that's the answer. It really depends on the problem we are trying to solve. And Java makes things a little bit more harder, but not impossible. We can always find a solution if we put our minds to it. Right? That's the beauty of the world we live in. And Java does have reflection, remember, right? Java does have quite a bit of capability that we normally tend not to use as much as we should really do. And then we start exploiting some of those capabilities. The next thing I want to talk about here is called the YAGNI principle. YAGNI stands for you aren't going to need it. Now, I have to say, this is one of the most challenging principles I've actually seen because programmers love writing code. And I've been working closely with programmers. If you ask me what I've done over the past 5 years, I've removed more code than write code. I go into companies and people say, Venkat, when you leave, we have less code than you came in, right? So I kind of entered in a weight loss program for code. And the point really is that we tend to write a lot of code which we don't need. When you sit down to design, what happens? Oh, I need this, I need this, I need this. We put several things together. And the minute we do all of that, what happens? We build complexity that we have to deal with. The YAGNI principle says you aren't going to need it. Now, sometimes people get apprehensive when you say you're not going to need it, especially, let's say you spend the time writing the code, right? You spend the entire day writing that code, and this morning I come and look at this and say, we don't need any of that code. What are you going to say? You're going to try to convince me, you know what, dude, I wrote this code yesterday. You better keep it. Right? Because you put the time writing it, nobody wants to be, the code taken away from them, right? But it's very easy to delete the code you never wrote. That is it's like, hey, I'm going to write this code. You don't need it. Thank you. I don't have to write that nonsense I was going to write, right? So what if you tell yourselves, do I really, really need it? And sometimes people get apprehensive. Well, what if I really need it? So I change this a little bit. I say, you aren't going to need it yet. And they're like, okay, can I do it tomorrow? Yes. And then next day you can say you can do it tomorrow. Be consistent, right? And then what happens? And time comes when, look, everything is working. Hey, what about that? I haven't still done that yet. Maybe we don't need it. So this is like the last responsible moment, right? You postpone writing something to a later time. Why? I think most of us can agree on one thing, right? You're going to be smarter tomorrow than you are today. Do you agree with that? I don't think anybody would say no, right? Absolutely, right? And we did not say this about the person next to us. That's a different question, right? But ourselves, we always say that. We're smarter tomorrow than we are today. And why so? Because we know more tomorrow about what we are doing than we do today. Our senses cloud, the problems come to us, and we think of all this complexity. So one of the skills we have to develop as programmers is really do postponing things. Ken Beck said really well, he said, courage is to postpone the work of tomorrow to tomorrow. And that courage doesn't exist in a lot of programmers. We have to say, I don't need that right now. I'm going to postpone that. And the YAGNI principle, I see this a lot when I work with programmers and I work with test-driven development. They would say, I got to create this. Like, I'm not going to need that. Let's postpone that, postpone that, postpone that. And what ends up happening is we end up having a lot of minimum code to get the things done. I've had people come to me and say, you got to be kidding me. I've got only a few lines of code and my solution is working. Instead, we had a monster before, right, that had to be, all these things had to be done. And it is like a sense of fresh air. You feel light. You're like, wow, I did not have to carry all the baggage of code with me. I write a lot less code. It's easier to maintain. How cool is that? So YAGNI principle is when you can postpone things until you can no longer postpone. So ask yourselves, is this something I have to do now, or is it something that can wait and I can implement something else without it? And you have to take a very drastic measure to do that in code to be able to achieve that. So, for example, I would take a problem and I would ask people, what are the classes you need to solve it? And invariably, there'll be like 7 or 8 classes they will identify. We'll write them down, we'll draw a UML diagram. Okay, here are 7 classes I have to build. And I would tell the programmers, go code this, and the next thing you know what they would do, they would implement all the 7 classes and come back and say, yep, all of them is done. And I would say, let's step back. Let's start with the first minimum thing we have to write, and we would write just one small thing, and we would be questioning and questioning and questioning, and when we are done, we typically end up implementing that logic with usually 1 class, potentially 2. And they're a little unhappy the first time. They sit there and say, we identified all of these classes. Why can't we write all of them? Well, because you don't need it, right? And that is something we have to develop a tendency for to avoid that, right? So that is what the YAGNI principle is, to really postpone things until the last responsible moment. One other thing I want to emphasize here is this single responsibility principle. I would say this is probably one of the most important principles we can ever think of. single responsibility principle. It talks about, there are two principles we want to follow in writing code. One is called cohesion, another is called coupling. And we want high cohesion and low coupling. So what does this mean? Our high cohesion. Cohesion is where things are glued together and they're sticking together and they're related with each other. Let me explain what cohesion means. When I was a kid, I know how it is to be a kid, right? When I was a kid, my poor parents had to put up with me. That was really hard for them. And I would come back from school, and I would be joyous that I don't have to be studying for a few hours. I can go out and play on the streets. So as soon as I come home, I'll open my drawer, throw things in there, barely, close the door, and run away to play on the street. And my parents would try to tell me, you know what? You don't keep things like this. We open your drawer. What a mess it is. There's a socks in there. There's a pant in there. There's a book in there. And other things we don't even know what those things are. Why do you do this? You put your clothes over here. You put your books over here. They tried teaching me this. But I never understood it, right? Because it was fun to throw things together and run away. But guess what would happen? One of those days, I would have to go somewhere important. I would come in, and I would need a sock. I would open this, and I would get a sock, a blue color sock, and guess what? There's only one of them. The other one is not to be found. And where do you find it? Among all this mess. And it would be really, really hard to find. What do? That's why you have little cousins at home, right? You call them and say, look for my socks. It's somewhere here in this house, right? And they go search. There's a search party looking for your sock. Is it this? Not that one. That one is stolen. That's not the color. And eventually you find one, you're great. And then you run away. Something is wrong with this, right? Now you may ask me, how did you fix that, Venkat? It was actually very simple. I got married, right? That took care of everything. My wife is not like my parents, right? You don't mess with the wife. Parents, they are kind of like, oh, little baby boy. Wife is like, I'm going to come to your room. It better be where it should be. Yes, ma'am. Right? So my underwears are well kept in one drawer. Books far away from it, guaranteed. Right? Sock in another drawer. This is called cohesion. So what does cohesion mean? Well, I was on a trip one of those days, and I really wanted a quote from a book. I know exactly what book it was from. And I called my wife and said, sweetie, can you do me a favor? I'm writing this little book, and I want to really get a quote on this book. And I know where this quote is, but I really want this right now. Go to my bookshelf on the second drawer, the third book. Can you please read out of it? That kind of discipline comes only from marriage, in my opinion, right? That happened to me, right? That really happened to me. And so now I know exactly where things are. 10,000 miles away, I can call my wife and say, that's where it is. That is cohesion. So cohesion is where you keep like things together and dislike things apart. And you want high cohesion. Coupling, on the other hand, is where you have dependencies. Now you may say, do you want to lower coupling? Absolutely. Well, one thing you could do is you could completely eliminate coupling. Nothing depends on nothing. Then what happens? The system will be so stable, nothing will run, right? So you cannot have that kind of, low coupling, right? So coupling is a necessary evil. Inheritance is a poor form of coupling. Because if you inherit from a class, you're depending on that class, hard to change. So you want loose coupling. So what is loose coupling? Depending on an interface is better than depending on a concrete class. That lowers your coupling. So cohesion and coupling are two principles we want to keep in mind. But single responsive principle directly attacks the cohesion. That you need to have one piece of code, narrow, focused, and does one thing and one thing well. And that is basically what cohesion, single responsive principle is. We can see this happen in a lot of places. Have you ever seen at work, well, let me rephrase the question. Who here thinks writing a long method is a good idea? Not a single person. All right, let me rephrase the question. Who here has seen long methods? Look at that. Almost everybody, right? Now, what's happening? We all know it's wrong. But we see long methods. Why? I know why. Because somebody at work, right now as we speak, is sitting down and making those methods longer, right? And they don't get it. Everybody here knows long methods are bad. What do? Brrr. And more, and more. I was like, why is this method? What's the longest method you have seen? How many lines? 400 lines. 800 lines. This is like auctioning. Right? It's sad. Sad. I'll stop this. I don't want to hear more. Right? The dude over there is like 12, he's raising about 12,000. Right? This is crazy stuff, right? You don't want long methods. And somebody there is like, you're talking about long methods, let me show you long classes. And the other day I was at a client site, right? I wanted to know what this method is doing. Reading. And I read some code. I'm like, okay, I understand, but there's more, and there's more. And now I'm like, how many lines more? Down. Still going. Oh, wait a minute. And then I use the tool to compare the line numbers. Oh, that many lines. I need a cup of coffee with aspirin, please. Right? It's long method. How do you comprehend that? So what's wrong with long methods? Let's put down a few reasons why long methods are so evil. Can you help me with that? Go ahead. What's wrong with long methods? Say louder for me. Oh, debugging is difficult. Hard to test. Multiple, lack of cohesion. Multiple responsibilities. What else? Hard to what? Maintain. Hard to reuse. Wonderful. Hard to reuse. Why? Well, here's the deal. This big code, long one, you're at work. Hey, you know what? I need that middle part. Well, how do I use that? Copy and paste it. So what does it do? Right? Leads to duplication, right? The programmer says, I didn't want to duplicate, but I had to. I didn't write this long method, they did. I'm the poor guy who has to maintain this code. So it leads to duplication, right? And we can go with this list even more and more and more. And yet what do you see people do? Heartlessly go make methods longer and longer. How do you correct these people? I got one last suggestion for you, right? Go back to work on Monday. Don't say a word. Sit down, start working. Your colleague who is not here, the one who makes methods longer, who doesn't listen to you, comes to work. Hey, you're already at work. Yeah. How was your weekend? You could say this. My weekend was great. I went to the park on Saturday with the kids. I went to the movie on Sunday. But don't say that. Oh, my weekend. Well, at 10 o'clock in the morning, I got in my car, put it in reverse, took the car out, went through the garage, turned left, stood there for about 30 seconds, took a left turn, walked, drove the light, and then took a right turn. There was a pigeon on this side, but that's never mind. Then I went a little bit more. Keep going like this, however long you can keep going. At some point, your colleague says, what? Have you gone mad? You say, no. I thought I would explain to you how the weekend was, like you write code. Right? Well, you don't talk to people like that, right? What do you tell people? Oh, my weekend was great. I went to the park on Saturday, went to the movies on Sunday, and your buddy says, really? Which park did you go to? Now, what's your buddy doing? Focusing in one area of detail. Hey, I want to know about this park. Oh, yeah, it's on this, this corner of the street in this place over here. Oh, is it kids friendly? Oh, yeah, there were a lot of kids playing. Hey, do they have real play areas there? What's the age group? Now we are going detail into the park, and the details of the park, we completely left out the movie out of the picture, right? That is really where we want to attack long methods. So the question is, okay, we don't want long methods, but how many lines of code should a long method have? Can you tell me how many lines of code it should have? I heard 20, I heard 30. Are you saying your age? And the reason I said, you can say your age is because the kid sitting next to you, who's a Ruby programmer, says, 20? No, it's got to be 7 lines of code. And the Clojure guy sitting next to them is like, 7 lines, we do everything in 3 lines. Right? So there's something wrong here. Well, here's another suggestion. What if a long method a method is short enough if you can see that entire method in one window? Now, don't try to lower the font size. Right? But that's another yardstick you could use. But even better than that, why don't we use a slap? No, I'm not asking you to go hit that poor developer writing code which is longer. Boom! Don't do this again. No, that's not a good workplace. SLAP stands for Single Level of Abstraction Principle. which is what we just did a few minutes ago, right? Single level of abstraction. Hey, how was your weekend? One level of abstraction. Drill down. Went to the park on Saturday, movies on Sunday. One level of abstraction. How was the park? Lower level of abstraction, right? So what if methods can focus on a single level of abstraction? It's not about the number of lines of code, but the level of abstraction. And that's what the SLAP principle says. Keep your methods focused on a single level of abstraction. How many times have you written a for loop, which is nested into a for loop, which is nested into another for loop? Yeah, so 3 levels down, right? And what does that mean? We are saying, I took a left turn, took a right turn, stopped, hey, there's a pigeon over there, right? We're going into details when we're not supposed to go into details, and that is really the idea, is that we want to keep it at that level. Slap it. Tell, don't ask principle. This one was hard for me, because TDA says, tell a piece of code what you want, rather than asking the code for values, taking action, and going back and telling it to do stuff. In a good object-oriented program, you want to tell the code to do stuff rather than ask for values, make decisions. I'll give you an example of this. I was pairing with a programmer. This is what I love about pairing. We get to learn from each other. And when you pair, you can challenge each other. You can say, why do you do this? Why do you do that? That happens to me a lot. People challenge what I do, and I end up learning in the process. I was pairing with a guy, and we were trying to implement a scheduler for a certain set of events. So we wrote the code. And the test was passing. And the test is passing, the code is here. We both looked at the code and said, what do you think? Remember the red, green refactoring? Well, it's green now, it's passing, but what do you think? We both looked at the code we had written collectively together, and we said, yeah, that sucks. We don't like it. And I asked him, yeah, I don't like it also, but what is it that you don't like? And he looks at this and says, yeah, you know what? I really don't know why I don't like it, but I feel it. Does that happen to you sometime? That you got a feeling, something is not right in this code, but I can't put my finger on it. So he kept staring at the code. Yeah, I don't like it too, but I'm not sure what it is that I don't like it. And a few minutes later, it's like, oh, I got it. I know what's happening in this code. And what we had done is we had put a loop and went to the scheduler and said, are you available? And if the scheduler was available, we said, book it. And wait a second, we are making the decision of booking by asking if it's available. And later on, if that decision were to change, we got to change in our code. Ends up usually violating the right principle as well. And the minute we realized it, it was like a light bulb going in our heads, right? Oh, darn it, we are violating the tell, don't ask principle. Immediately we changed it to simply saying, here's a collection of schedules, schedule and give us the very first one available. Bam! The loop was gone, it became declarative and functional in style, and all that we had to say is, here's a collection of schedules, book the first one and give us what was scheduled. And that was like lifting a burden out of our shoulders. We didn't have to do the looping anymore. And all that we had to do is tell this collection to go find the first one that's available, and the responsibility was transferred over to the scheduler rather than us doing it. And this is a little hard because sometimes you got to know, and it clicks, and it's like, oh, I know what principle I'm violating here. And then the answer was like a couple of seconds later, of course, right? It's like knowing this, and then you're going to solve it right away. So that's basically what tell, don't ask principle says. One of my most favorite principles is the open-closed principle. Open-closed principle says that a software module must be open for extension but closed from modification. Meaning, you want to be able to extend the software, but not by changing the code, but by really employing polymorphism. And open-source principle is a very important principle that meets extensibility quite a bit. And I want to quickly give you an example of this. Suppose I had, let's say, a class called car, and the class car had an engine, let's say engine, and I'm going to have an engine reference. I'm going to use Java example here. Now within this class, I'm going to say a constructor for car, and I'm going to say it takes another car, let's say car other. And in this case, if I say other, and what is going to happen within this code? I'm going to say this engine equals new engine, and I'm going to say other dot engine, right? So notice what we just did in this example in the copy constructor. Well, we said my car's engine is equal to a copy of the other car's engine. We know that Java does not have copy constructor, so we wrote one ourselves. Well, what is the problem with this? The problem with this is it will work fine for a while until 3 months later, you said class turbo engine is going to extend, so extends from engine. Now, if you pass a turbo engine to the car, when you make a copy of the car, you end up getting an engine, not a turbo engine. Why? Because a constructor is not polymorphic. Well, one way to save this trouble would be to go back and say, well, here's another way to save this trouble, right? Rather than doing this, you could fix the problem. What you could do to fix the problem is, you could say, well, here's an idea. Let's go back to the code and say, if other.engine instance of turbo engine, then engine equals new turbo engine. You can write the code for that. Else, engine equals new engine and write the code for it. That solves the problem, right? You're happy with it? No. What's wrong? Come on, think positively all the time. That's job security. Because every few months we keep changing it, right? Stay employed, right? Well, of course, that kind of stinks after a while. We don't no longer want to do the job, right? Why? You got to keep babysitting this code. That's a violation of open-closed principle. The only way to extend this copy constructor is by physically changing it. And so what do? We could employ a clone method, for example, right? So what could we do? We could have said, rather than doing this, we could have said, don't do that. Instead, simply say engine equals other.engine.clone. And of course, you got to cast it to an engine, and you could do it this way. Make sense? Well, that's only half the problem. If you read Effective Java book says, don't use clone, use a copy constructor. And I was like, darn it, I've been telling people not to use copy constructor. These guys tell people to use copy constructor. Who is wrong? And so both of us are wrong. And the point really is, you cannot solve this problem so easily. If you're interested, you can go to my website. I've got articles related to this, and I show how to solve this problem by using a combination of constructor and copy clone method. And the reason the clone method would end up failing is that it really has to rely upon copying object, but clone doesn't work when you have read-only or final properties. Unfortunately, not really designed for it. So anyway, but you have to really come to that point where you say, I'm going to take care of those principles. One of my other favorite principles is called the Liskov substitution principle. Liskov substitution principle says that you should use inheritance only when you want substitutability. Inheritance is one of the most abused concepts in object-oriented programming. How many times do we read the book? And the book says, delegation is better than inheritance. What do you say? Absolutely true. Thank you, brother. And then you turn over and type inheritance. Why? Because Java doesn't support delegation so easily, right? It makes inheritance so easy, simple to use. But let's look at an example here for a minute. Let's say for a second I have a class here called vector. Now what does the vector do? You can insert anywhere, right? Insert anywhere and remove from anywhere, right? So that's basically what a vector is. Now you have a function, and the function accepts a vector, and what do you do with this vector that you pass? You can pass that vector to other function, fn2, and you can pass it down, right? You can keep passing it down and do stuff with it. Now I come along and I say class stack extends vector. So why did I really extend a stack from a vector? What is the reason for it? Well, it's very simple. I can then simply reuse the implementation of the vector, right? I don't have to rewrite it. In fact, if you go back and look at the class called stack in the JDK, that's exactly what they did. They inherited stack from vector. What do you think of this inheritance? Good or bad? Go, be bold. Bad. Why is it bad? Because I create a stack. Remember what a property of a stack is? LIFO, right? Last in, first out. So I create a stack, and I say stack You are last in, first out. Push, pop, and the stack is smiling at me, right? It's like, awesome, thank you. And I send it stack to his function. What is his function? His function is F1, right? And what does he do? He takes the stack as what? A vector. And what does it? He passes it to him. What does he do? Hey, vector. And the stack comes back, so how are you doing? Well, you shouldn't have sent me over there to that neighborhood. Poor stack, it's been mangled, right? Completely abused. And it's like, I'm not going to work with you anymore, right? And so poor stack was mistreated as a vector, right? That inheritance, C++ had this really bad concept called private inheritance. I hate that. But that's what we're trying to do here without saying it's private. We really wanted to reuse the implementation, but not be treated as. That's what List cost efficient principle says. Don't do that, right? Because if you do, it becomes really hard. Delegation is better than inheritance in cases like that. So the only time you use inheritance is when you really want substitutability. That this code is actually usable in place of the other object. That's when you want to use inheritance. And the last thing I want to mention to you is dependency inversion principle. And I'm going to mention this without a code example, with just an example of real-life situation. So this was a long time ago. This was my first trip to Norway. And I've been to Norway maybe about 50 times now, but I was like a guy going to Norway for the first time, a foreign country. So I go there on a Sunday, settle down, and I looked around in the room, and they didn't have a coffee machine. And I'm a coffee addict. I have to have coffee, and there was no coffee machine. Like, where's coffee here? So I went down to the reception and said, hey, you need a coffee machine in my room. And they said, we don't give coffee machine to people. I said, I would die if you don't. I got to have coffee. It's like, okay. And they went and brought a coffee machine, gave it to me, and said, be happy with it. So I was like happy. So it was close into the evening. I wanted to go to bed. I go to bed in good hours usually, wake up very early in the morning. And I looked around, and I was a bit of a shock. There was no alarm in the room. I said to myself, what's up with these Norwegian hotels? They don't have coffee machines, they don't have alarms, actually clock, so they didn't have a clock in the room. So I went down to the reception and said, yeah, may I help you? This guy is back again, right? I said, the room doesn't have a clock. And they said, yeah, we don't give clocks. And this was before the time of cell phones, right? We don't give clocks. I said, well, that's going to be hard for me. And they said, why? Why do you need a clock? Well, without a clock, how do I wake up? And the lady, Norwegian lady, was very confused. She said, I don't understand. Why do you need a clock to wake up? And I'm trying to explain to her, well, I always have a clock. And you know this clock makes a buzz, such an ugly sound, that I cannot sleep for the next day? And she said, oh, you need an alarm. And I stared at her for a minute. You're correcting my English? And you're right. I need an alarm. Why did I say clock? Because I use a clock. And guess what my clock has? An alarm. I don't need an alarm. I need a clock. I need an alarm. She said, you need an alarm. I said, immediately in my mind, I'm drawing a UML diagram, right? A clock inherits an alarm. Makes sense, right? Awesome. I said, yes, you got it. I need an alarm. And she said, well, there's an alarm in your room. I said, really? I didn't see the alarm. She said, did you turn on the TV? I said, no, I don't watch TV. Well, this week you will. I said, okay. And I went back to the room, and like, remote, hey, here's the remote. And I click. If you come to my room today, you'll find out the remote is exactly where they left. I never touch it, right? And I'm like, oh, here's the remote. Click, and the TV comes up. It says, dear Venkat Subramaniam, they even know my name. This is awesome. And I kind of press with it, and it says, this is your alarm too. I'm like, she was right. And you could use the TV as an alarm. What a novel concept, right? And you could use the TV as an alarm. And of course, I'm a guy who's really behind test-driven development. So what do? Set the TV's alarm for 2 minutes from now, turn it off, go brush my teeth, come back, beep, oh, it's working, right? And it turned on to CNN. I was like a little curious. I would put it on another channel, set it for another 2 minutes, and wait for a few minutes. Beep, it comes back. Guess what? Back on CNN. I was like, that's kind of weird, but that's okay, as long as it works. So I set it to like 4 in the morning, and I usually don't have jet lags. I sleep like a baby, so I just went to bed. And now I am, you gotta imagine this, right? How cool this is. Now I'm in a room which is dark, completely dark. And I don't have a clue where I am. And I'm in this dark room, and this lady has taught me a lesson that there could be a clock and there could be a TV, and both of those inherit this alarm interface, right? And suddenly, I hear a noise in the room, and the noise is increasing by the minute. I jump out of the bed, I don't have a clue where I am, and all I can see is a TV in front of me that's on for no reason. And I find the remote, I'm lowering the volume, it's 4 in the morning, and there's this guy in front of me with suspenders saying, "Hello, this is Larry King Live." Can you imagine waking to Larry King Live in the morning? I had to go to therapy when I went back home. This is hard stuff, right? And the entire week, part of the week, I had to use the TV. But, I mean, honestly, I don't watch TV, and I don't want to wake up to Larry King Live. So what did I do? On the third day, I wrote a little program that will wake me up by making a noise on my computer. So I don't have to listen to Larry King Live. So now I have a computer implementing the alarm interface, and guess what? When I was a kid, I had the world's best grandma. And I would tell my grandma, "Grandma, I got an exam, can you please wake me at 4 o'clock? Very promptly at 2 o'clock, she'll wake me up and say, "Don't worry, I'm awake, I'll wake up at 4. Right? And so my grandma could be an interface for alarm. And look at now what happened. I was deeply coupled to this clock, but I really didn't want a clock. I wanted the alarm. And the Norwegian reception told me, "Your dependency is messed up. You need to depend on an alarm and not a clock." And now I can use various different types of alarms. I use my cell phone as an alarm, and in a very tiring day, I call my lovely wife and say, "Sweetie, I'm going to wake up at 3, but if I don't call you at 3, please call me by any means. Send thugs over, whatever you have to do. But I need to be up at this time," right? So you can have multiple implementations that you could use. So the idea really is, by decoupling from something concrete, you can make it very extensible. This is called dependency inversion. So you have a code that depends on something concrete. Instead you said, "No, don't depend on concrete. Raise your dependency to an abstraction, an interface, and let both the code now depend on this abstraction," and you got the dependency inversion going for you. And I would say things like mocking, Spring, all of those heavily influence dependency inversion principle. I find these principles to be very, very interesting to use in a daily basis during test-driven development, during regular programming. But these principles give more meaning to the design I'm creating. And so when I work with programmers on a daily basis, we use these terms. "Hey, that code you're writing violates open-close principle. Are you wondering about LSP over here? Why don't we use DIP?" We don't use patterns as much. We communicate more using these principles. I hope you found that useful. Thank you.